Hey guys and gals. Hey guys and gals. How you doing? How are you doing? Give me a sec here. Oh, okay, there we go. Okay, was supposed to do that. I gotta click back here.
Plug in.
Bear with me, guys. I have to kind of go backwards here just for a sec with my videos. Skip. Pause. Okay, there we go. Yeah, I just had a little bit of a oops, but we got it fixed. We're good. We are good. How is it going? How is it going? Welcome, welcome. Welcome back again, guys and gals. Quickly do some quick mod stuff, and then we are gonna get going. We're going to be learning. Let's get some learning done. Oh, new subscriber. Let's go. Where'd you come from? I love it. Let's go. Quick mod stuff. Okay, perfect. We're good. You guys can hear me. Let's go. Another subscriber. Yes. That's awesome. Great to see. That's so great to see. I love it. I love it, guys. You guys keep me pumped up. I will say that, every time. Positive vibes. We're keeping the positive vibes going. I love it. Keep it up, guys. Remember, sharing is caring. And I love it that you love the content. Whatever reason it was that made you click the subscribe button, I must have been doing something right on that video. Let's go. I like to pump you guys up a little bit, get you excited. Get your mindset to do some learning because, hey, guys, gals, positive vibes, right? We're working towards becoming the 120 and above IQ club. Let's go. That's a great idea, right? Here to support parents, homeschooling parents. That's kind of the idea. Help you guys out, your parents. You parents? Homeschooling your child or your children. I support you in your decision. I understand, fully understand. Here to help however I can. Hopefully I can. Will do my best, right? Just to get, I don't know, try to keep it short here. I'm trying, guys. Students are also welcome. Students, hey, you're totally 100% welcome as well to follow along the videos in the series if you need. You may be searching YouTube or whatever because maybe you have a cruddy duddy teacher that's might not be fully teaching, which is what they should be doing. But regardless, to let you parents and the students know, I'm gonna fully do my best to stay on topic. I may, kind of go little side stories and stuff once in a while, but for the most part, I'm gonna keep it strictly either school related or work and life related or something to that effect. Okay. But for the most part, yeah, we're gonna be talking mathematics. I love math. Also, I feel I'm more qualified than the fake degree instructor, because I call them fake degrees because, well, if they're not teaching what they're supposed to be teaching, then they must have a fake degree. What else do you call it? So that makes me more qualified because I'm teaching mathematics. Again, I was lucky and blessed, guys and gals, to have instructors that actually taught mathematics and physics and all those classes. I was blessed. So therefore equals I learned and I excelled and I did well in said classes. I was top of my class. Okay? I'm not going to feed you lies and garbly gook. Okay? I honestly not trying to toot my own horn or whatever. I'm trying to be modest here. Okay? But I did well. Okay? Let's just say it clicked for me. Okay? So because of that, especially with algebra and that, because algebra clicked for me and all the little things that are related to mathematics, I also excelled in calculus. Okay, it has been a number of years since I've been in college, but again, I was in a time when teachers were teaching the subject, and that's all they did. So I was, again, yes, blessed. So there you go. That's that little story. Let's carry on. Welcome, welcome. It's great to have you guys and gals. We are going to continue. We're working on, this is technically speaking Unit 5. It could be whatever unit, but we're basically working on geometry, shapes, 2D shapes for the most part. And we're slowly getting into, well, we're talking about triangles and you're learning about angles and supplementary angles and complementary angles. If you're just following and coming into the series right now, I recommend you start the series from the beginning. The terminology in that is kind of important. For the most part, I have majority of the terminology down. For me, terminology is good to know, right? But I don't know. You don't need to know 100% the deep details. If you have an understanding and you can do it and it just makes sense, just roll with it, sort of thing. Some little concepts I kind of mess up once in a while, but for the most part, we got majority of them. Let's just get into it. Okay. So I'll bring up some images. Is that this one? Yeah, here we go. So your basic shapes, right? We're working mostly, we're not really, these are nice to know, be aware of, right? But for the most part, we're working with, you're going to see right triangles a lot, guys, in your future, okay? So get used to seeing the right triangle. Know that this symbol means 90 degrees. Okay, it's a perfect these two lines here are 90 degrees. So perpendicular is another term, right? To each other. And then we could just add this extra line here, connect the points, if you will, and we've actually created a shape out of it. Essentially, that's kind of, in a nutshell, that's what we're doing. Right triangles have, there's a lot involved with right triangles. Now, don't get scared. There's a lot of different ways to solve a problem with right triangles. I'm just going to say that. You have more options, and it's great. It truly is. There's always some way you can attack a right triangle problem and solve it. Just depends on what formulas or whichever method or approach you want to use. Okay? So here's some terminology we should be aware of. Like, we'll just look at these two lines here. I mean, I guess it doesn't matter if it's these two lines. These are line segments, technically speaking, but they're joined at a vertices, right? But as you can see, these angles are less than 90 degrees. Same with this one. Okay, and as you can see, it says acute. So you might as well get used to that. Just, I have an acute angle here, right? I call this a narrow angle, right? It's narrow. And then you have what I call this one a wider angle. So I'll kind of talk about them in that reference, which is an angle that is greater than 90 degrees. Okay? In regards to symbols, the greater than and less than, just look at it this way. This is how I do it. I'm going to put a number here. I'm going to put a number here. Okay? The way I look at it, the mouth is going to always want to eat the largest piece. And I just look at it, pretend it's a Pac-Man. Waka, 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 waka. Pac-Man's hungry. He wants to eat the larger ghost. I don't know. We can pretend it's a ghost. Waka, 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 waka. Right? There you go. What's that? What's that? Oh my goodness. It almost looks like one. Among Us? It's an Among Us Pac-Man ghost. Let's go! That was just randomly made too, guys and gals. I did not expect it to look like that. But anyways, that's what I do. So it doesn't matter if the 8's on this side or if the 6 is on this side. It's still going to be the same direction. Okay? Waka, 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 waka. I don't have the sounds. What's that sound? I wonder if I could find that. Pac-Man. Hang on, hold up. I'm kind of wasting time, guys. I'm sorry. Pac-Man eating ghost sound effect. Let's see if we get it. Let's do it. Oh, that's eating. That's the eating sound. But I want the actual, like... Okay. Maybe not that one. Let's see. Let's see this one. Okay, that's kind of the sound. 8-bit digital. Yeah, that's the sound of when he's actually eating it. Okay, let's get back to work, guys. I just thought I'd throw that in for fun. Old school. It was fun, very popular. Nothing like the old arcade, hanging out the old arcades. It's good times. Good times. Oh yeah. Okay. Let's continue. All right. Back to here. So, yeah. I don't think there was anything else. Was there anything else you needed to talk about that? We're going to get into talking about, the terminology a little bit. Let's kind of refresh our brain. And then same thing with straight angle. Okay, basically a straight angle is a straight line, right? So, like, let's say you had an angle, or not an angle, but a line that was rotating, and it rotated from starting here, and it rotated all the way down to here. Okay, this is the pivot point. Okay, and then now it's perfectly flat and horizontal again. Okay, basically that's a straight line. Okay, or a 100. So it equals. Okay, so I'm just gonna draw it randomly here, and that equals 180 degrees. Okay, right? So, which is, basic kind of common sense, right? You got a flat line. Let's just call it a linear line. Not really kind of liking that term, but the other term. But yes, okay? Straight line, that's it, straight line. Okay, we were going to get into some other problems here coming up. Let's see, we'll go here. And we'll close this. And let's see, I have some other stuff we can look at. Do I have more definitions? I think so. Oh, that's a bell curve. Obtuse. I didn't really care for these, so we're going to skip that. We're going to be getting into this slowly, so you might as well just kind of get familiar with it. We're not going to be doing anything yet, but see and be aware of. We're going to eventually get into that. Other things, triangles. Any triangle, all triangles, all interior angles add up to 180 degrees. Okay, so there's that concept. Going back here, actually, yeah, there was some good material in here as well. So we could scroll back here and reflect. Yeah, the sum of the angles of a triangle is 180 degrees. It's just simply, if you know them, if they're given, you just add them all up, right? But if there's one that's unknown, well, it's just simply 180. Let's say A is unknown. It'd be 180 subtract B subtract C. Okay? So we have reflex angle. We're not really working with that much. Again, if you've been following this series, you'll know what that is. I recommend you do that. For the most part, we're going to be talking about. Let's see how I could do this. We have the acute, right? And then we have the obtuse. Now, if I actually go like this, I'm going to go like this. So an acute angle would go here. Okay, it's less than 90. Okay, so an acute angle could be there as well, guys. Okay. Anywhere in between 0 and 90. And then you also have an obtuse one. Okay. Again, center here, this is the pivot point. Alright, guys? And that is anywhere between 90 and 180. The reflex ones are basically these ones. Essentially, they're kind of the same thing, except, of course, instead of going from there, it's going to be going all the way here. I know I kind of drew that sloppily. Let's do that so it doesn't look so bad. Okay. There we go. It's a little bit better, right? So the angle is going to be greater. And again, it's greater than 180 and less than 360. And a reflex can also be in this quadrant as well. Okay, we're just kind of recapping here, okay, guys? So, greater than 270, right? So, reflex. So, really, I mean, I guess we could be working with some of these, but it just depends on the orientation, the shape, whatever we're working with. Okay? Now I call these quadrants, right? This area here is all quadrant 1, right? And then same thing here. This is all quadrant 2. Anything in here in between, 90 and 180. Quadrant 3, quadrant 4. Okay? So you'll hear me talk about this a little bit. You don't really need to know the in-depth details. Just have an understanding. If you see this, this is kind of like working towards graphing, so don't let it scare you. Graphing could be, you have kind of like the integer grid, right? This could be 1, this could be 2, this could be 3. And of course, you're going to have the same thing with vertical, right? So it's just like anything. So I could go 1, 2, 3, right? Let's say you have a coordinate system, which is kind of like X and Y. I shouldn't be talking about this yet, but just to kind of give you an idea. So this is X, this is Y. Let's say you're given a coordinate of, I don't know, 3-2. So basically it's going to be jumps. 1, 2, 3 jumps. That's in the X direction. 2 jumps in the Y direction. Again, look at the sign. They're both positive. Right? So you're going to go up 2 jumps. So we're going to have a line that kind of... So that's going to be it. So it's just basically a dot. And then you could draw a line from here. Whoops. From here and right through your intersection. Okay? Straight line. Right? Right through that point. Okay, I'm going to clean that up. We're not going to get into that too much, but just so you have an idea. Okay? Kind of going a little further than I need to. That's okay. All right, so let's talk about, so let's say I have 2 parallel lines, okay? Now, I know they're not going to be perfect, but I'm going to try, okay? Not bad. And then let's say I have a, was it a transversal? Transversal. Again, this is going to be a line segment. So line segment will normally have arrows at both ends. Okay. And then so now the question is, okay, let's see. We need to kind of go over some. Do I have that open still? Let's see. Close that. Well, that was it. Okay. Not this one. Maybe this one. Yeah, this is what I'm looking for. This is what I'm looking for. Okay, we're going to be talking about alternate angles and such again. Okay. Again, quick refresher. So we have alternate angles. So it's, you have your transversal line, right? That's what it's called. Transversal. Yes. Okay. Anytime you see this singular line intersecting or crossing through 2 parallel lines, that's the transversal. That's the transversal. That's the transversal. Okay, so we're talking about, we want to get familiar with alternate angles. Okay, I look at this as the narrow angle, the narrow angle. Okay, both narrow angles are going to have the exact same angle. Okay, right? The only way these angles will change if let's say, they never will unless you have 2 broken lines, right? So this part would have to be at a different rotation, which it's not. It's a singular line. So because it's a singular line going at that angle, it's consistent, it's unchanged, that therefore equals these angles are going to be the same, right? Exactly the same. Imagine this as a straight line. right? So if we continue this angle, that's 180 degrees, right? So that means this angle plus this angle equals 180 degrees. Okay, correct? Again, reflecting, complementary angles add up to 90 degrees. So essentially, that would be, let's say I had a line through here. We have an angle here and we have an angle here. As you can see, they both would add up to 90 degrees, right? So they're called complementary. Okay, supplementary, just think of it like the triangle concept. You could have two or more angles, right? For supplementary. Okay, two or more. As you can see, we have three here. All right, congruent angles. Congruent means the same. Again, you could have two shapes. One could be scaled larger, as long as these lines don't change direction or are not rotated. They're gonna have the exact same angle. So, like in AutoCAD, for example, I could take a shape, I could copy it. It's gonna be pointing and going in the same direction, and it's going to have the exact same angle. I could scale it. I could scale it 2 times the size. The angle is unchanged. Nothing changes. Okay, you can scale it. The only thing that changes is the length of the lines. That's all. We have opposite angles. C is opposite D. A is opposite B. Again, we talked about perpendicular lines, and here we are talking about parallel lines and the transversal. Okay, you can pause and read that if you like. This is kind of what we need to get into. We need to talk about this. And this is kind of what I wanted to get into. I'm going to close that because our information's kind of right here. Corresponding angles. Okay, they're corresponding. You can see it's there and it's there. They're congruent, and they're in the same side of the transversal. So I guess they're corresponding. A pair of angles on the same side, yes. Hold up. I don't really want to cancel the commercial. It's a coding commercial. That's okay, I support coding. Okay. What else? A measure of corresponding angles are equal. Yes. Okay. So because look, right, you can see they're both wider angles. Wider. That's kind of why I want to bring up the concept. Narrow. Narrow. Okay. I haven't drawn it perfectly, but all these are the interior angles and they're all the narrow angles. So therefore, they're all going to equal the same, right? They're all going to equal theta. Theta, let's say, for example, is equal to, I don't know, just some random number. But it has to be less than 90, right? So, I don't know. Could be anything, really. Let's say it's 65 degrees. Just as a wild guess. Okay? 65. Okay, going back to this. Alternate interior. Okay, so they're inside. So interior are between the two parallel lines. So I even have to try to remember this too. I don't focus too much on this terminology as much as I do focusing on congruent, perpendicular, parallel, opposite, these little formulas, complementary and supplementary. I focus on these more. They're more important to me when trying to solve shapes and such, and angles and what else not. It's nice to know this is kind of like, to me, this is kind of like extra additional information. It's not really critical to solving a problem. Okay? But it doesn't hurt to be aware of them. If you don't have them perfectly memorized, I wouldn't worry about it. I would focus more on remembering complementary is 90, supplementary is 180. This little formula essentially is supplementary angles formula for a triangle. Essentially, right here we have a situation or an instance where it's complementary because they add up to 90, right? Two angles. And then we have a straight adding up to 180 here as an example. X and X here are complementary, okay? If we add up all of it, that would be supplementary, right? Okay, let's carry on. And then what else? Yeah, things like you should know what congruent means. You should know what it means when somebody says opposite angles. A and B are opposite each other. You should know what perpendicular lines are and parallel lines, and what a transversal line is. And then here, these are just additional extra concepts, I think. But they could be on your exam. You never know. Alternate interior. So think inside, inside. Interior, inside, inside. They're alternate each other. But again, you can see they're congruent by the looks of it. Right? This is a narrow angle. This is a narrow angle. And then same side interior, which makes sense. So anytime you hear interior, just think in between the parallel lines, I guess. Could be a way of looking at it. Okay, we've kind of been through this. This is extra information. If you want to pause, you can read that. We talked about polygons and that a little bit, didn't we? And we've been through this. We did this problem. We did these. I showed you how to do that. I'm not sure. I don't recall if we did this one. I don't think we did. But anyways, I wanted to continue with some other problems. This is the example we're working on right now, okay? The question is, in the figure on the right, which is this one, name the 4 pairs of opposite angles. Okay, opposite angles. There's 4 pairs. 1 pair, 2 pairs. We see 2 right now. 3. So I'm gonna go like this. Maybe go a little wider, or just go like this. Didn't really want to erase all that, but so we have 1 pair. No. 1 pair, 2 pairs. Okay. All right. Opposite angles. And then we have the wider ones. These are opposite each other as well, guys. Okay. So that's 1 pair, 2 pairs, 3 pairs, 4 pairs. That's done. Okay, name the 2 pairs of alternate interior. Okay, alternate interior. Alternate interior right there, essentially. So there's 2 pairs. So 1 and 2, yeah. Inside. Yes, inside. Don't mess that up. So that's 1 pair, and then this would be the 2nd pair. Okay? And then the 4 pairs of corresponding angles. Corresponding. Maybe we'll have to go over that term. Do we have that terminology? Oh, here it is. Corresponding angles, a pair of angles on the same side. Right. So there's going to be 4. Okay. They're congruent angles on the same side. So that's 1, 2. I imagine they're going to be like this. 1, 2. 3. So that's 1, 2. Same side. Did I mess that up? I hope not. Oh yeah, they could be opposite and outside. Yeah. So yeah, I was focused on the inside concept. So I guess that's the other little thing to kind of remember. When they're talking about corresponding angles, it could be outside your parallel lines, as you can see. Again, when you see the word interior, those are the angles that are in between the parallel lines. Okay? Little tips to help you kind of try to remember, that's all. Okay, so we're looking for the 4 pairs of corresponding. So, I know I did 3. Kind of messed it up. So, 1, 2. It would make sense that this is the other one. And then it would make sense. So I've done that. So essentially it's going to be all of this. And then all of this. Okay, this one with this one, and this one with this one. 4 pairs of corresponding angles. And that is done. Okay. How are we doing for time? Good, I hope. Not bad. Quick coffee. And we're going to keep going. Okay, guys? All right. Okay. So, thank you for watching that part. I mean, it kind of doesn't hurt to kind of refresh your memory in case you've kind of been away from watching it a few days. Alright, so we have, and I'm just going to try to draw, there we go, good enough. I could put the arrows, it's not really necessary, but we'll just add them anyways. Again, guys, if you have scrap paper and such and you want to kind of write these down, you can by all means. So they've given us a problem here. Not really a problem, but this is the information that's given. Okay, so we have, now looking at it, 71 degrees is less than 90, right? So therefore, what do we have? We have an acute. We have an acute angle less than 90 degrees, right? Therefore, that's our narrow angle, okay? Narrow. All right. Okay, good. So what are they asking? In each figure, indicate if the pairs of lines, L1, so they've named the lines. Okay, so this is line 1, line 2. These are subscripts. Sub means base or bottom. So if I draw an L and I go like that, that means subscript. Okay? It's just basically, this is line number 1, this is line number 2. Really, that's all it is. There's nothing too deep or too technical about it. Okay? Alright, so indicate if the pair of lines L1 and L2 are parallel, perpendicular, or neither. Okay, well that's easy. L1 and L2 are parallel. So that solves that problem. That was quick. I didn't even really need to do all that extra drawing. So I'll just draw the lines without the arrows. Okay, just assume they're perfectly drawn lines. Okay, so this is L1, this is L2. And I'll just go like this just so that's our transversal, okay? Is L1 and L2 parallel, perpendicular, or neither? Well, it doesn't matter about orientation. They're still parallel to each other. Okay? Just like the last problem that we had, guys and gals, orientation doesn't matter. Whoops. Okay, going back to the first problem. Right, here's the transversal. Right, it's just a different orientation, but they're still parallel to each other. Okay? Orientation is no different than saying, like, if you're holding a cup and you're just rotating it in midair. Okay, that's orientation. Okay. Let's go like this. Let's do a third one. Trying my best to draw straight lines. Okay, and then we have another one. And I'm going to go like this so you guys know that this is perpendicular. Okay? And then we're going to have a line that goes like that. And this is L1. And this is, well, I could go here, L2. And they just gave us some angles. I'll just put 29. If you know one angle, you can quickly and easily figure out the other angle. Okay? Simple math, right? Okay, so looking at this, L1 and L2 are perpendicular to each other.
When you travel well,
That's great! Traveling? I don't have money to travel. I'm not high society. Who has money for traveling? Traveling? What's that? I haven't even been out of my own country. Ever. More commercials. What's up? I'm just waiting for the commercials so I can skip it. Hope it's not too loud. I'm kind of guessing on the volume here. Okay, there we go. That's all. Oops, back to this. Not, this is just kind of, part of mathematics, guys and gals. They just want you to know the basics, right? Doesn't hurt to know. Okay, and then L1 and L2. And of course, this is going to be your transversal. It's just a singular line intersecting two parallel lines, right? And then they've given us an angle here, 61 degrees. Okay. I'm going to say parallel. Now, do we have a neither? Which one is neither? Parallel, parallel, perpendicular, and parallel. That's what I'm getting. Okay, so this is parallel. Pretty straightforward, right? You guys are kind of like, yeah, that's enough for that. That's pretty easy stuff. Could we have something more challenging? Okay. Not a problem. Anything you like. Okay, so we have a line. This is called line 2. Guess I'll just write it here. Did we do this one over? Yeah, we kind of did this one in the one video. We did. This is where you're supposed to draw a line that was perpendicular or parallel through a point. Pretty straightforward. I just say you can measure a distance perpendicular, draw a point, measure a distance, measure the distance, and then measure the distance, draw a point, and then draw a line. That would solve that problem real quick. Essentially, it's just draw another parallel line. Nothing too seriously complicated. You guys got this, right? Oh yeah, you do. Totally do. Okay, here we go. Let's get into some math a little bit. Without measuring, okay, that's a horizontal line. And I'm going to try to draw another one. It's not perfect, guys, I know. I'm going to try to draw a parallel line. That's not too bad. Could be worse. This is our transversal. And then we could go line 1, line 2 if we want. Doesn't matter. And we could also put arrows on them if we want. Doesn't matter. So they've given us an angle here, which is 72 degrees. And they've given us some information, X and Y. Have I done some of these already? I don't know. I don't think I have, but hopefully not. Okay, so the question is, without measuring, find the missing values of X and Y. Okay? And that's why we kind of went over the terminology a little bit, right? As soon as you have an understanding, as soon as you know that we have two parallel lines, they're perfect straight lines going at whichever angle. In this case, it's kind of, whatever this is, we have to figure it out. It's going at that angle, and we have a horizontal plane, perfectly flat. Just imagine that it's a perfectly drawn straight line, guys and gals. Appreciate that. And then let's figure out X and Y. So with the concepts, right, this is a narrow angle. So with that terminology, we're not inside, so they're not interior. So I guess they would be called corresponding. So therefore, because this is a narrow angle and this is a narrow angle, and these are perfectly parallel lines, and this is a perfectly horizontal line intersecting, right? Angles are not going to change, right? So therefore, X is also going to equal 72 degrees. Okay? Not square root. There we go. Check. So what is Y? Okay? Y is the straight line concept, right? You have a straight line. A straight line adds up to 180 degrees, right? Imagine this is X and it just rotated about this point. Poof. Okay? 180 degree angle. Okay? So therefore, that said, we could easily figure out Y here. Y is going to equal to, right? There you go. There's your 180 right there. Y equals 180. We could, oh, actually, I should go like this. Y equals 180 degrees, subtract x. Right? Makes sense to you guys? Totally does. I know, you're smart, beautiful, intelligent people. You got this.
Help defeat our
Oh,
biggest.
hold up. Why are there so many commercials on this today? More than normal. They're double commercials too. Skip. Okay, let's continue. Should have wrote it a little bit higher. 180 degrees, subtract 72 degrees. Y equals, do we do the long math? 180, 72. Subtract, borrow, 10 take away 2 is 8, 7 take away 7 is 0. That's it? What? No, drop the 1. 108. Right, guys? It is, yes. Dun, 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 dun. Perfect. Drop the A's. Oh, don't forget your degree symbol. Okay. All right, let's do some more. Okay, so we have 2 parallel lines. Eesh. That's gonna have to do. I'm trying to be a little bit of a perfectionist, but okay, good enough. Okay, this is our transversal. I'm just gonna draw arrows on it just to separate it. This could be L1. This could be L2. Okay, and they've given us right here 80 degrees. Okay, that's right there. I'm gonna go like that just so that we can represent it. So take notes. So X and Y. Okay, so X is an interior. Okay, so the concept is, I know it's going to be an interior. Alternates, that's the one, right? They're alternate each other. So I know that this is the narrow angle. Okay, it's kind of a little bit difficult. I almost have this line drawn perpendicular. And I'm going to change that so you can actually visually see it better. So I'm going to change the angle a little bit just so we know, right? Terrible arrows. One. I freehand on paper with a pencil better than this, okay? Okay, guys. Now this is going to be a little bit exaggerated, but that's 80 degrees. And as you can see, this is our narrow angle. X and Y. same thing. This is our narrow angle. So again, it's going to be x is equal to 80 degrees. Same concept, right? So to figure out y, well, it's just a matter of going. I know that's kind of drawn terribly. Because I drew my y a little bit large. X is equal to 80. Therefore, same thing. Y is going to equal to 180 subtract x. Okay? So 180 take away 80, right? You're going to be left with 100, right, guys? All right. Easy peasy, lemon squeezy. You know it is. Dun, dun, dun. And yeah, so I figured this out, right? Because it's interior between the two parallel lines. This is a narrow angle. I know this is going to be an alternate interior angle. And then we have y is basically, well, it's alternate. Is that what they call it? Alternate? It's kind of like the neighbor. So I know that this is a straight line. Therefore, y is going to equal to 180 subtract x. Okay, hopefully you understand. Right? Just keep it simple, guys. Just keep it simple in your mind. Okay, so I'm going to draw kind of two horizontal lines. And then I'm going to have a line going like this. Close enough. And they've given us 105 degrees. This is our transversal. This is line 1, line 2. Our two parallel lines. And they have x here and y here. Okay? So this is obviously greater than 90, right? So therefore this must be our obtuse angle, right?
So,
Obtuse is that, right? Obtuse angle. I have to get rid of this commercial. I don't know why it's nailing me with so many commercials this time. It's crazy. YouTube, I don't know if you like me or not. What's up? All right. Okay, so that means, how do we look at this? Well, what's that term again? That is, I know this is not interior. Corresponding? Corresponding, yes. Corresponding. So that means this angle here is also going to be 105 degrees, right? You just got to kind of figure it out. So this is corresponding to that. These two, x and y, are alternate. I mean opposite. My bad, guys. Caught my little mistake. Opposite. X and y are opposites. Okay, so therefore, this means, since they're opposite, this means x is going to equal to y. Okay, they're the narrow angles. Narrow, narrow. So to figure out x and y, it doesn't matter if I use x or y. I could do x first. It's going to be the same calculation, guys, gals. Right, remember, x is equal to y. So they're both going to equal the exact same amount in value. 180 subtract 105. Now if I take off 100, that's going to leave me with 80, and I subtract another 5, that leaves me with 75 degrees. I did the math in my head. 180 subtract 105, 75. Boom yays. We're just getting familiar with figuring out angles based on, 3 lines, right? Eventually it's going to be working into triangles and shapes, and then you'll be able to visually see angles and go, oh yeah, this side's this, right? Again, the concept is, here we have 2 parallel lines. They're exactly on the same plane, going in the same direction. They're perfectly horizontal lines. They're straight lines. And we have a singular transversal line intersecting through both our parallel lines. Okay? The values don't change because, again, our transversal line is a linear straight line and its angle's not unchanged, right? So therefore equals this angle is going to equal this angle. It's just the way it works out. Okay, what are we doing for time here? Oh, that's it. Wow. That is it. Okay, hopefully you enjoyed that. We do have more we're going to go through. I wish you could tell me yourselves if that's kind of good enough. I have some more problems we could work through, but I don't know. We'll see how it goes. Thank you for watching. Parents, children, be good to your parents, right? Just get your homework done. You could do it, right? Keep a positive mind. You get your homework done, and then your parents will let you kind of have, some you time or fun time or whatever. Students as well, appreciate you being here learning. Hopefully I could help you. Hopefully I'm helping. That's kind of the goal. Lots to do, lots of stuff in mathematics, so stay tuned, and we'll see you in the next video. Take care for now. Johnny with Whiskey Tango Sharp, coding/mathematics. I appreciate you, and wherever you are, have a great rest of your day. Take care for now. Peace.